Hello, welcome to today's class. And in today's class, we'll be checking lesson 2 of difference equation. And today we are going to check the finite difference operators. So let's start. So first we will check the forward finite difference operator. And also, if you have not watched the first lesson of difference equation, I will urge you to watch the lesson 1 of difference equation for you to understand the introduction of this topic. Alright, forward finite difference operators. If you have this symbol stand for your forward finite difference. So your forward finite difference of f of x is equals to one increment, which is your f into bracket x plus h minus your f of x. So if your function is in the form of y subscript 0, so the forward difference also, the forward finite difference is equals to one increment, which is y1 minus your previous y0. So with that also you can also find your forward finite difference for y subscript 2. That will be y subscript 1 rather. That will be your y2 minus y1. So the logic is that whenever you are finding the forward finite difference of a function, you take a one increment, that be a step forward, subtract from the previous, which is your f of x. So let's check some example. On this example 1, we have solve forward finite difference of sin x. So in the solution now, we just take an increment of your sin x, which is your h, that will be sin into bracket x plus h, and then minus the previous one, which is sin x. Likewise, you also check another example for better understanding. If you have forward finite difference of arctan x, so for the forward finite difference of arctan x, we have an increment step forward, that is arctan x plus h minus arctan x. And don't forget your trigonometric ratio. We have arctan A minus arctan B. Alright, is also equals to arctan open bracket the first angle, which is A, and the negative sign here, or whatever portion be here, what is here as your minus, then the next angle, which is B, over 1 plus the first angle times the second angle. So we apply the same thing to this. Our first angle here is h plus h, and that's why we have h plus h here. And because it is subtraction that is here, then we also have it here. So then the angle for the second is x, and that's why we have x here. Then we follow this rule, we have our denominator also. So x minus x give us 0, and what will be left in our numerator is h, and that's why we have this one here. Then we also have 1 plus, and then once you use this to open this bracket, you are going to have your s squared plus sh. I believe you understand that. Alright, you can try this by following what we just did now, and I believe you should be able to find this for finite difference interesting. Alright, I want to go to the second operator under finite difference, which is the backward finite difference. Alright, and the forward finite difference also of f of x, so that will give you f of x. That is what you have here. You have here then you now subtract an increment, subtraction of an increment, that is f of x minus f of x minus h, whereas our forward finite difference is given as f of s plus h minus f of x. So you can see the difference between the forward and then the backward finite difference. And please make sure that you don't mix up the two. Alright, so for y subscript n, we have your y subscript n minus y subscript n minus 1. Alright, that's for the first order. This is the first order of finite difference. So for the second order, that is when you have your operator to be square. So the logic is just that since this is square, that means that this into two places, and that is your del times del f of x. So by the time you find the backward finite difference of f of x, you are going to have f of x minus f of x minus h. So by the time you use this to open the bracket, so you are going to have this times this, which give you backward forward difference of f of x, and also minus your del f of x minus h. So by the time you find the backward finite difference of this, you are going to have f of x minus f of x minus h, and then you have your subtraction, and then we have this also f of x minus h minus this already h before, so another increment you are going to have 2h, another increment, and then you are going to have 3h, another increment you are going to have 4h, like that. Alright, so by the time we use this minus to open this bracket, we are going to have f of s minus h, minus times minus give you plus, so you are going to have f of s minus 2h. So you can now add up this, and this is minus f of s minus h minus f of s minus h, and that give you minus f of s minus 2f of s minus h plus f into bracket s minus 2h, and that give you the second order. Likewise, you can also share the second order when your function is in this form. You can see that we have the same thing. Alright, so let's check backward finite difference operator examples. Now, example 1 we have here is we have to find your del square sine x, the backward difference square of sin x rather. Alright, so we also follow the same rule. So by the time we split this, we split this delta square, we are going to have del times del sin x. So that is backward del sin x. Alright, by the time you find the backward del sin x, we are going to have sin x minus sin s minus h. Alright, by the time we use this to open this bracket, this time this we devote this, and then this also, and this also we have this. So then we find it individually. The backward difference of sin s is going to give us sin s minus h. I believe that is clear now. Now also for the second one, this already an increment, one more increment here minus 2h, and then you have this. So you use this to open the bracket. Then we have your sin x minus that is I jumped a step here, that by the time you use this minus times this, you're going to have minus sin s minus h, and that and this, and then with this you are going to have minus 2 sin s minus h. Then minus times minus, you have your plus, then you have your sin x minus 2h, and that gives you your final answer. Alright, also let's check another example on that backward finite difference rather. Okay, we have to find the backward finite difference square of exponential x. Okay, we also split this into 2. So we have your del times the exponential x. So by the time you find this, you have exponential x minus exponential x minus h. Alright, so then likewise you also use this to open the bracket. So you have your delta for your backward delta exponential x minus backward exponential x minus h. And when you find this, you have this exponential x minus exponential x minus h. Then your minus here, because this negative will affect everything in this bracket. So by the time you find it, then the backward difference of exponential s minus h, you have exponential s minus h minus exponential s minus h. Then we open the bracket. Alright, by the time you open the bracket, you are going to have exponential x, this minus this minus this, that minus exponential s minus h minus exponential s minus h. You are going to have minus 2 exponential x minus h plus exponential s minus 2h. Alright, we can see that exponential s is common to all these terms, so we are going to factorize our exponential x. So by the time we divide this exponential s by exponential s, we have 1 left. By the time you divide with this, you are going to have minus 2 exponential minus h plus exponential minus 2h, and that gives you the final answer. Alright, I believe you are able to have the understanding of the finite difference method, and if not, I will just urge you that you go back to the lesson from the beginning. And if you have any question, you can just drop it at the comment section, or if you have any contribution. Thank you for watching once again, and don't forget to subscribe to this channel so we continue in lesson 3. Thank you, and then stay blessed.